Let's take a look at some consequences of this really terrific inscribed angles theorem. So look at this. Here's a circle with lots and lots and lots and lots and lots of chords. Let's take a look and see if we can parse this really carefully. I want us to focus on angle C. Well, technically, I guess it's angle ACB, but I'll just call it angle C. So I want us to focus on that angle versus the angle D versus the angle at E. Now, those angles are all over the place, and they all look sort of unrelated. But let's think about those angles for a second. Well, notice that that angle is actually an inscribed angle because it comes from these two chords. And notice that actually those two chords sort of span out this particular arc. So we could actually find the measure of this angle by taking the measure of this arc and taking half of it. Okay, fine. But now look at this angle. That's also a different inscribed angle, and that inscribed angle actually comes from these two chords, but notice those two chords actually capture the same arc. That means that the measure of this angle is going to be equal to 1/2 the measure of this arc. So what about the measures of these two angles? They're equal because they both have captured within them the same arc. What about angle E? Well, that's an inscribed angle that actually comes from the same arc again. So the really cool thing is the way these are drawn, we see that the measure of angle C is equal to the measure of angle D, which is equal to the measure of angle E. And so by a theorem, we know that all these angles are congruent. That is a really cool fact. And actually, a wonderful consequence of this theorem, which actually has some utility. Let me show you how practical this really is. Let's suppose that we were playing Chinese checkers. And all of a sudden, we had this hankering for figuring out angles. Right? So we stop the game, hold the game for 2 seconds, and let's take a look at what we've got. So suppose that when we measure, we see that, in fact, this little angle right here this inscribed angle is 50 degrees. And suppose that we know that this arc, RS, is 110 degrees. The challenge for us, before we return to our game, is to see if we can find the measure of angle QZR. So our goal is to figure out this angle right there. And again, it's one of these questions that I really like because it seems like it's impossible. But let's take it slowly. Okay, now, what do we know? Well, I know that since this is an inscribed angle, I can actually figure out the length of this arc. Why? By this formula. Because the angle is going to equal half the arc measure. So if this is 50, then this must have been 100. So I see that this measure is 100. Well, but wait a minute. This also is the arc associated with these two chords and this particular inscribed angle. So what does that mean? It means that the measure of this angle must be half of this, 50. So if this is 50, that tells me that this must be 50, and that was the principle we just saw. So in fact, this angle right here is 50 degrees. I'm looking for this angle. Notice I've got a little teeny triangle here. I know this is 50. I want this. Oh boy, oh boy, oh boy, oh boy. If I could figure out that angle, I could use the fact that the sum of the angles of a triangle equal 180 degrees. I'd be home free. Is there any way for me to find that angle? Well, how's that angle formed? It's formed by this chord and this chord. Hey, wait a minute. That angle right there is an inscribed angle. Here's the arc. Whoa! And that arc we know is 110. Yes! Because since that's 110, I can plug it in and find the measure of the angle. It's going to be 1/2 of 110, which I happen to know is 55. This is 55 degrees. I've got a little teeny triangle here, and I know two of the angles, 55 and 50. And so if I add up 55 and 50, what do I see? I'd see 105. I know the total sum of the area of the angles is going to be 180, and I have 105, which leaves how much for this angle, the angle I want? That angle must be 75 degrees. And so the measure of angle QZR equals 75 degrees. Look at the great power of this wonderful inscribed angles theorem.